Hello everyone, Croeso nôl, welcome back. And our last session of the day here on the Wales Tech Week headline stage is some of the world's most powerful technologies, and they all begin life in Wales. Home to the world's first compound semiconductor cluster, Wales is delivering breakthroughs that are transforming the world, from AI and electric vehicles to green energy systems of tomorrow. So our panel, in collaboration with Wales Tech Week Gold partner Vishay, will explore how Wales's world-class compound semiconductor ecosystem is solving global challenges, driving economic growth, and enabling critical industries in Wales. The discussion will be chaired by Dr. Drew Nelson, OBE. Now, Drew co-founded IQE in 1988 and served as CEO for over 20 years, building it into the global leader in advanced semiconductor wafer technologies. He also created CS Connected in South Wales, the world's first compound semiconductor cluster, which is recognised internationally and has been instrumental in shaping the UK's semiconductor strategy. His contributions have been widely recognised, including an OBE for services to the UK electronics industry. So please join me in welcoming Dr. Drew Nelson, OBE, to the stage.
Thanks very much for the introduction. And I hope everyone's enjoying Wales Tech Week so far. We're a whole day not even one day into it. So I'm chairing the panel, and as you can see, the title is Made in Wales, Powering the World. Wales has an advantage in compound semiconductors. I'm joined by 5 esteemed panelists, one of which is from Vishay. And as Vishay are one of the gold sponsors, it's time to learn a little bit about Vishay with a very short video. There we go. So Vishay came to Wales about a year and a half ago, and they're investing a huge amount of money. So they are extremely welcome to Wales, and thank you for making the investment. So before we bring the panelists on, I just want to say a few words about the compound semi cluster. It basically consists of a number of companies along the technology readiness level scale and institutions. Starting with Swansea University and Cardiff University. They've both invested huge amounts of money, about £100 million each, into compound semiconductor research and development facilities and innovation at the TRL 1 to 4 level. Then we have the Compound Semiconductor Applications Catapult, which does prototyping, design, and testing for various companies. That's at TRL levels 4 to 6. And then we have what we call the core 4 manufacturers, IQE making wafers, Vishay making chips, KLA making equipment, and Microchip making packaged chips. And they span the food chain of making packaged devices for industry. Between them, the companies employ about 3,000 people. Employment's grown 32% since 2020, so that's a great feat of growth, powered by people like Vishay and also by KLA Tenco, who have cited their European headquarters. KLA is a very large American company. They've cited their European headquarters right here in Wales, in amongst the cluster, attracted by the ecosystem that's around them. We expect to try to grow the cluster to about 5,000 or 6,000 employees by 2030. Now, just as important as the number of jobs is the quality of those jobs. And the jobs in this industry are very highly skilled, very highly paid, and very sticky. And so the national salary of companies in the cluster is at least twice the national average. And you can see from the amount of GVA that's created, 350 million to the Welsh economy. This is about per employee, about 3 times the national average. And then as you can see, about 90% of the product is exported. But actually in the design of the cluster, it was meant to provide an engine of growth for UK industry as well. And so the technology that comes out of this, packaged compound semiconductor, advanced semiconductor chips, is there to provide the base for all of the industrial verticals within the UK in the industrial strategy. And in fact, the Right Honourable Rachel Reeves, the Chancellor of the Exchequer, visited the cluster a few months ago, and in particular she visited Vichy. And what she said was, this is exactly the type of investment that will help us grow the economy, create highly skilled jobs, and boost opportunity for people across the country. So I hope she lives by her word and invests in the industrial strategy in semiconductor manufacturing, particularly in Wales. This is a heat map of the cluster. You can see the core 4 manufacturing companies, KLA, IQE, Vishay, and Microchip. And then we have the compound semi applications catapult and the 2 universities I mentioned. But this is a map of the supply chains as well. And you can see that not only is the wealth and jobs being created along the M4 corridor, but it's permeating way up into the valleys. And this is fantastic for giving hope and inspiration to thousands of people up the valleys who are supplying the main 4 companies for manufacturing. So finally, you will have no net zero without compound semiconductors, particularly materials called silicon carbide and gallium nitride. They are critical for instance, clean energy, offshore wind turbines and solar energy farms. They're critical to data centers because they reduce the amount of power consumed by data centers by up to 30 or 40%. And they're critical for electric vehicles, not only making it very fast to charge, but also increasing the distance that cars can travel before they need recharging. So with that, let me introduce you to the various panel members, and I'll invite them to come up and introduce themselves. Round of applause for the panelists. Okay, you ready? So what I'd like to do is, first of all, ask each of you to introduce yourselves, say a little bit about yourself, your company, and its role within the cluster. And I'll start off with you at the end there, Mike. And you've got no more than 2 minutes. Avril, who organized this whole thing, is keeping us on a very tight time schedule.
Okay, I'll keep it brief. Mike O'Sullivan, very pleased to be here. I'm Chief Administrative and Legal Officer for Vishay, and have been working very closely with the team here since our acquisition a 1.5 years ago, as Drew mentioned. We're excited about where we are with the Newport wafer fab, and more excited about where we're headed with it.
Yes, my name is Rolf Hellinger. I'm coming from Erlangen, from Siemens, so from Germany. And I'm responsible at Siemens for the technology and pre-development of power electronics, for motion control, but also for the overarching company core technology. Very pleased to be here. Thank you.
So my name is Rodney Pelzel. I'm the Chief Operating Officer and Chief Technology Officer of IQE. We make compound semiconductor wafers. So we are the starting materials for, and you would know us in the cell phones that you have, and actually the internet that you use, the chips that we make power all of that. And South Wales is the where we were headquartered, and it's where all our innovation certainly has grown from.
Good afternoon, everybody. My name's Caroline O'Brien. I'm CEO of the Compound Semiconductor Applications Catapult. I've been in post just coming up 2 months, so I'm new into this, but I'm not new to the semiconductor industry or to the South Wales cluster either. So the Compound Semiconductor Applications Catapult focuses on scaling SMEs and products from early stage TRL 3 to 4 all the way up to TRL 6. We've got some great capabilities in photonics, RF, packaging, and also we've got a very strong base in power. So I'm very pleased to be here today.
Afternoon, everybody. Well, pleased to be here. I'm Professor Owen Guy from Swansea University, and I'm at our CISM fab, our Centre for Integrative Semiconductor Materials, which, as Drew mentioned, is our 60 million pounds fab. So I'm responsible in part for training the next generation of talent to work in the fantastic companies KLA, Microchip, Vishay, and IQE, and the growing ecosystem around that of small companies that are emerging.
Okay, thanks everybody. So I've got a series of questions. I'll ask some of the questions to all the panel and other questions to very specific members of the panel. So here's a little teaser to start. What one product or service do you supply that could change the world? Mike.
Great question. So we have products that literally were on the Mars rover, that were part of the mission with the India moon landing last year and satellites orbiting today. So we think of our products beyond just changing the world. But I think we have a very broad portfolio of products, for sure, but really bringing it more home to where we are now, without a doubt, is silicon carbide. As you mentioned in the opening, silicon carbide has the power to change almost everything we do and everything we touch, and really change how we even manage our infrastructure and our energy. It's a foundational piece.
Okay, thanks. Rolf?
Yeah. We help our customers to transform their processes, especially in industry, to make them more competitive, faster, and more sustainable. And how do we do that? We bring the digital world and the real world together, and that is done by power electronics. And silicon carbide and gallium nitride are the new stars from our perspective in this game. So why is power electronics so important for net zero and for these applications you have seen? At the end of the day, power electronics can be the sensor and can influence the system, and this is even more decisive.
So at IQE, we're in a very good position in the fact that we do gallium nitride, certainly, for power. So I'm certainly a believer in that. And what Drew said is that net zero doesn't happen. I don't think people fully digest that. So you won't be able to have AI data centers scaling the way that they're planning on scaling if you don't do something. You can't build the power fast enough. So gallium nitride and silicon carbide have to be there for that. And then I think the other one is there's a myriad of materials that we're in that emit and detect light, just like a spectrometer, and they can do spectroscopy on your blood. And if you combine that with AI, in terms of what could actually change the world, is you could literally wear something on you that would tell you if you should go see the doctor, or if you're sick, or if you might get sick. And if you combine that spectroscopy and that ability to detect with AI's ability to actually interrogate the data, that's really impressive. So that's what I think is actually even probably a little bit above power electronics. Not that I don't believe in power electronics.
So as probably you're aware, the Catapult basically provides services to SMEs across Wales and across the UK. So that, without a shadow of a doubt, is really our main focus for services. But because of the unique way we're funded, we also have the opportunity, this is through Innovate UK, we're partly funded through that and also through our commercial activities. We also have the opportunity to invest in some core technologies, and those are really very exciting for us. And actually they use silicon carbide and GaN. So really investing in solid state transformers, which we're applying today to more intelligent grids, but we believe has a place in the future in AI data centers and supporting effectively from the grid to the data center. So that's one area where we're very excited. The other area is also actually using AI to develop power electronic systems and components and to integrate them into sub-assemblies. And we see that as certainly one of our strings to our bow. And we've used that in anger with certain customers to be able to more quickly design their power electronic systems.
Everybody has already mentioned silicon carbide and GaN power devices, gallium nitride power devices. And actually, I'm going to echo that. I think those are the biggest things in Wales and our biggest contribution in that area in power electronics, because it powers everything: electric vehicles, artificial intelligence, renewable energy. Anything you think of that needs power, high power is going to use those. And the second thing I want to mention, the big silicon carbide conference, Ice Cream, is coming to Newport in 2027, September 2027. That's going to bring the world, the silicon carbide and gallium nitride world, to Newport. So I think that is going to change the world, Drew.
Thank you. So that's a date for the diaries. Yeah, and you can see we're not only changing the world,
My colleague Mike Jennings is the conference chair.
Okay. So next question is more specifically to the industrialists here. There are a lot of stories about South Wales and industrial decline. Why are you investing here, and what are you planning as future investments? And as a follow-up to that, what one thing could the government do to encourage you to invest more? And if the Chancellor were here, what would you say to her?
I didn't get the last sentence from you. I didn't hear it, the last sentence from you.
Oh, so it's why are you investing here in the first instance? Second thing is, what would encourage you to invest more? What government initiatives
Understood.
could be put in place? And if the Chancellor was here, she's a very busy lady this week. And if she were here, what would you say to her?
Yeah, I mean, it's a good question. The question is, why is Siemens the global player here in South Wales? And to be honest, there are two reasons. First reason is we had to investigate where is the place to be if we want to step even more in the power electronics business, especially with compound semiconductors. And we investigated all over the world, several regions, and at the end of the day, we came to Wales. And the point is, the environment and the research and innovation ecosystem here, with science on the one side, with design competence, with the Catapult Center here, and at the end of the day also the manufacturing sites which are here. This is really unique, and this is why we are here. We started, or we entered innovation partnership with the compound semiconductor application Catapult, and we are co-located, so we are really here in Newport, and we bring together there the deep knowledge of semiconductors with packaging technology and with application know-how of Siemens and of small and medium-sized enterprises here and of startups. And with this together, we are leveraging, I would say, really a research and innovation system to come to the next level of power electronics. So what is the next level of power electronics from our side? It's software defined on the one hand and more dematerialized. Sounds strange for hardware guys, but what we really want to reduce is the, let's say, the periphery hardware, yeah, what we want to get out. And this is, of course, also something what helps us to become much more sustainable. And we are not talking about 5 or 10% reduction in material. We are talking about 50 to 80% reduction in material, and we have already products in the market for that.
And what else could the government do to encourage you to invest more?
I think, first of all, we should focus here on our strengths, what we already have. And if we would get support to attract even more small and medium-sized enterprises and even more startups and even more talents, then this would be a great support. And this could be done, of course, with investments in the right direction of research and development, but also on infrastructure.
Okay, thanks.
So IQE is a global company. So we have sites in the US. We also have a site in Taiwan, and we have one right here in South Wales. So why is this the headquarters? And the environment, the innovation environment, is certainly driving that. So some of the world's cutting edge innovation in compound semiconductor happens right here. It's also a very safe geopolitical place in the world to do R&D as compared to other parts of the world. So there are very good reasons for us to do it, both from a innovation perspective, a scientific perspective, but also from a corporate perspective. And what would I say to the Chancellor? I agree with you, you need to focus on your strengths. And I also think you need to really get real in terms of what it's going to take to actually fund semiconductors. And it's not just about innovation, it's about scale. It's about scaling it up. It's about taking it to a level that's mass production. And quite honestly, the West is losing that race to the East. And more specifically, the UK is losing that race to the rest of Europe. And so what I would say is you have a tremendous asset. Capitalize on it and develop it and scale it.
Okay, Mike, I know you've hosted the Chancellor fairly recently at Vichy. What did you ask her?
We were very happy to host her recently. I think she enjoyed her visit. Hopefully what she saw reinforced the commitment that exists today to the work that's going on, the partnerships that exist inside the cluster, and the support that has been given to the universities. I think that's critical. We need to continue to innovate. Of course, that requires appropriate funding for our universities and the research they're doing. We also need the talent that's coming out of the universities. There's 3,000 skilled semiconductor workers today in the cluster. You mentioned that in the opening, and we think we're going to need double that number in the next 5 years or so. So we need our universities to continue to produce that, and we need full support for our universities to produce that talent. The reason that Vichy is here is very similar to what you said, that it comes down to the people and the talent and the passion of the people in Wales, the people who we've met, the people who are at our facility, the people who are supporting the work that we're doing at the universities, with the government. And it comes down to the resources and the collaboration within the cluster. It's very unique. And like Siemens, we've looked at this across the globe. And this is an incredible, unique environment that exists here. And if I could tell a little story about that, our founder, Dr. Zaman, created Vishay 60 plus years ago. And it's an impressive story from a corporate perspective. We're 60 plus years old, US public company, global footprint, all of that. And I would encourage anyone to look into that further and learn more about Vishay. But what's really more extraordinary is actually his life before he became a physicist and invented our key products at the beginning and formed the company. It was how he survived the Holocaust when most of his family did it. He lived in a pit that was dug underneath the bedroom of a house in Poland. And he lived there in this 1.5 square meter pit for 17 months with 3 other people, including his uncle, who taught him advanced math and trigonometry in the dirt in this pit. But because of that experience, and because he obviously demonstrated a great amount of resiliency and fortitude, I know that today he would be so invigorated by what's happening in Wales. He would really love the passion of the people in Wales and the resiliency. As we all know, in this area, there's a transformation in the industries, and everyone here is part of that. He would be so invigorated by that development and want to be part of it. He would see immediately why we're in Wales.
That's a really powerful story. Thanks for sharing, Mike. Okay, moving on. A couple of questions for Carol and Owen here. How do we diversify our workforce and get more women into the industry? Caroline.
I think Owen should answer that first. I might be a bit biased. Yeah, it's always a difficult one, but I'd like to start by saying that actually in materials and material science type companies, compound semiconductors particularly, we do actually have quite a high proportion of females in the cluster itself. And I think I can see 2 of the other CEOs of compound semiconductor companies here, obviously Jutta of IQE as well. So there's at least 4 female CEOs in the cluster. So I think with the compound semiconductor side, we do actually quite well. And that actually goes across the UK as well. We've got Georgia Longobardi running Cambridge GaN Devices. And I have to give a shout out to Dr. Rachel Oliver as well, who runs the Centre for Gallium Nitride in Cambridge University, because she's really, I think, is a fantastic role model for us all. But I think, you know, it obviously starts at a young age and your interests. And I think, you know, some of the companies here have been really proactive. We've been really proactive in promoting, particularly across South Wales, you know, that it is actually an opportunity for everybody. And there is something within all our companies that people can do. And I think that's really important. But we also have a problem with retention. And I think that's to do with how our you know, workforces are organised, and I think we can do more there to make sure it's inclusive, you know, for you know, not just women but just a diverse workforce generally. You know, the Catapult is a good example, as I'm sure some of my fellow panelists' companies are, in terms of nationalities, and in terms of equality as well. So I think, you know, it sort of goes in the right direction, but I think, you know, we do have to be conscious of it and pay particular heed to it, because it's not something that necessarily that's going to happen organically. So I think, you know, we've got an aging workforce more generally within the industry, and, you know, some people that have been in the industry 40 years, you know, I know are retiring, and all that knowledge and all that capability is retiring with them. It's hard to replace. The only way we're going to replace it is by bringing people into the industry. And I think, you know, we can do a lot more there to promote our companies, you know, to extol how exciting it is, and that really it's a fantastic career. And I think we'd all agree here that it, you know, it is a career that you can be proud of.
Okay, thanks. Owen.
Starting them young. Primary schools, that's where we start. There's very little difference in the approach of those young kids. They're all super enthusiastic, and we can inspire them. We've got a huge range of activities, initiatives. Dragons Rugby with Vichy has a schools program which is exceptional. So that's where we start. Then looking at a broader diversity in terms of subjects coming into the industry. So maybe people think, oh, it's only electrical engineers who go into the industry. But actually, it's much broader than that. There's chemists, physicists. One of my star PhD students is a geneticist. They now work at KLA. And the third thing I'll mention is incentivize it. I introduced some of my students. I brought a busload of students up with me today, introduced some of them to Caroline, who incidentally is a Swansea alumnus, which is fantastic. Give them internships. Offer them sponsored projects. That's the way to target your investment and get the talent on board.
Okay, thanks. Very insightful. So another one for the industrialists here. We've seen real uncertainty in the supply chains driven by geopolitics. The Dutch government taken over Nexperia, and I'm not sure whether it's been handed back again, but anyway. And then there's the trade war over advanced chips between the US and China. How can we ensure reliable supply of chips to customers, particularly in the UK, but also in Europe? Mike?
This is certainly an issue we follow closely on really a daily basis. It's been dynamic the last few years with the geopolitical currents and how they ebb and flow. How do we ensure supply chain stability? This is one of the key questions that we had to answer for the UK government when we were making our bid to acquire the Newport wafer fab. Now, we felt very confident in our ability to show that as a US public company, as a close ally to the UK. And for sure, I think that's part of the answer. And that's certainly what we're telling our customers and our key stakeholders, that we have solutions in the Western world where we can supply chips reliably, and we can secure supply chains, and we can preserve national security interests for many Western nations. I think obviously you're seeing the regionalization of supply chains in the semiconductor space. It's been decades of globalization, so we're not going to unwind that in 2 or 3 years. But I think everyone here can point to evidence that it's happening. I don't see that changing. I think we'll continue to see that evolve into more regional supply chains. It's certainly how we're looking at our business and managing our future. I suspect you'll hear similar responses as responsible companies are doing.
Yeah, I can only underline what you said. So, I mean, latest since COVID-19, we know how fragile our supply chains are, right? And nowadays, with the geopolitical situation, it's even more difficult. What we are doing is we are convinced that we need to have regional supply chains at the end of the day for the different regions of the world. And therefore, we need more and more to incorporate local partners and build up local partnerships again.
Okay.
Yeah, I would agree in terms of you will see regionalization of the supply chains. But I think, again, it goes back to really recognizing what's at stake. And so semiconductors is really the oil of our generation. It's absolutely essential for national security, for defense, for everything that we do daily. And so with that comes a need for that regional support in the region, UK support in the region, from all different perspectives, from talent to funding. Otherwise, you may find a situation where you don't have the chips that are absolutely critical for national security.
Okay, thanks. So we tackled the question of how to encourage more women into the industry. This is a more general question about skills specifically. Do you feel that you have got the skilled workforce that you need? And if you don't, then what other initiatives do you think could be taken to enhance the skills of the workforce so that you get what you want? And I'll ask that to Rodney, to Mike, and to Owen.
So I certainly think that we've done very well in our regions in terms of attracting talent, and this is a great place to attract talent for compound semiconductors. But in answer to your question, the answer is no. I don't think that we have exactly what we require, especially in terms of redundancy and what's coming next. And I also think it's also the next generation of the way in which you think and the way in which engineers are trained and the way in which we have thinking agility. So the solutions that we need to come up with aren't just straight linear electrical engineering or chemical engineering. They're different, which is actually altering the way in which your educational programs even happen, and partnering with industry, I think, is very, very critical. And so from my perspective, that's really the answer. It's a very, very tight partnership with the educational institutions. It's thinking outside the box in the way in which you educate people. And it's also, I fully agree with starting very young. And so it's setting that mindset, and all of that needs to happen to really develop that talent pipeline.
Yeah, Mike.
Okay. From my perspective, I think yes, we have a lack of experts and also of workforce. On the other hand, I think we have a huge opportunity now because the young people want to change the world. They want to make the world more sustainable and let's say, take action at the end of the day. And this is exactly what you can do here. So you have seen power electronics and especially compound semiconductors are really the game changers. The game changers for a sustainable environment, for a sustainable world. And we can keep our life standard if we can use this and make use of that. And this is why I think young people will step into this business. Yeah. On the other hand, what we are doing at Siemens, we have a lack internally too. And due to the retirement of the baby boomers, this will become even bigger, this gap. And we, let's say, educate our own people, of course. I think this is what each company does. But we also educate dual curriculum students, so students which are partly in part-time in our company. And this is also, let's say, a very good relationship and a very good way to bring people into, or young people into the company. Yeah, and at the end of the day, we also educate unskilled workers to skilled workers with examination. Yeah, and I think this is also a good chance to increase the skilled work.
I'll be brief because I agree. I think we've covered the corporate side pretty well. But to answer your question, we're very happy with the workforce we have. It was a driving reason for why we wanted to move forward on the acquisition of the Newport wafer fab, and we think we're going to need more. we absolutely think we're going to need more, as I alluded to earlier, and we need to start early. And I'm interested to hear what Owen's position is from an academia perspective. I think that's an important one.
Well, those are the guys providing the pipeline.
Yeah, we just need more. We just need to guide more of our students into the right pathways. We have the facilities at Swansea and Cardiff to train those to a very high standard. We're also working with further education colleges to train people and re-educate or re-skill people and reinforce and add to people's skills. So we have those courses available. We just need to promote that and give those courses and that training to a larger number of people.
Thank you. So I do agree with my fellow panelists here, but I also want to add, we also play our part. We've got a number of researchers in residence at the Catapult. We also have interns as well. I think overall, and I think, Vichy is a fantastic example of this, having more inward investment into the South Wales cluster will help accelerate, these transitions into workforce. It will also attract other people from different areas to come into the semiconductor area specifically. And I think that would help upskill all of the workforce and all of the different requirements needed from places like Vichy, who are really doing from the bottom up in terms of capabilities. So I think there's exciting opportunities there, and that's what I'd ask the Chancellor, whether we can have more inward investment.
Okay, thanks. That's pretty much the questions that I have. I'm just going to ask the audience in a couple of minutes to see if they have any questions, but just one last final thought from the panelists. Give me one word or snappy little phrase that describes the cluster, and also one word or snappy little phrase that describes Wales. And whoever the winner is will get a part-time contract with CS Connected. Mike.
For the cluster, I would say essential. And for Wales, passionate.
Yeah, for the cluster, I would say innovation engine. And for Wales, it's a place to be.
So for the cluster, I would say punching above its weight. And for Wales, I would say that it's quite resilient.
The cluster's unique, and it still is today, which is fantastic for Wales, maybe not so great for other places across the UK, but the South Wales cluster is unique. For Wales, I'm going to say ambitious. I'm not quite sure if we're there yet, but I'd love to be able to say it in the not too distant future.
So cluster, I would say world leading in terms of some of the technologies, the compound semiconductor technologies that we do. And for Wales, passionate about manufacturing.
Great answers. Great answers, guys. So a round of applause for the panelists. Howard Ruprecht there, he'll be asking for some more snappy phrases, presumably. Anyway, are there any questions that the audience would like to ask any of the panelists? Right down here in the front.
Hi there. Thank you for the panel. I guess picking up on the final point around the talent piece, I'm interested to sort of understand what capacity exists currently to train and develop new talent coming through the pipeline. And the second question, perhaps more to the commercial piece, is to what extent is there a unified strategy and unified approach to co-identifying the talent and the skills that you guys are going to need to fuel the growth that you're talking about?
Anybody want to take that? Mike?
So for sure, we can take a more unified approach, although I think we're all saying a lot of the same things in terms of the type of technical skills that are really required regardless of exactly where you are in the semiconductor supply chain. We need talented physicists, chemists, electrical engineers. We need people who are talented with IT and with human resources. I mean, we need all sorts of talent to run a commercial operation. So I think we're unified in that sense. In terms of capacity, it's a great question, and I think each of us has that concern. Where concern is probably not the right word, but we recognize the talent that's here, and we recognize how well it was put together with the resources available in the cluster, and it's being absorbed, right? And you look, you walk around the Tech Week, and you see every booth has a company that's impressive and needs more talent, right? No one here no one has their booth up because we're announcing we're going to shrink. You know, everyone is here because they intend to grow. So we need to continue to build capacity. I don't have an exact answer. I can't tell you exactly how much capacity exists today, but I know it's being absorbed, and we believe we need to double it soon. So we want to certainly do everything we can to support that from the Vishay side. You know, we're doing that from promoting apprenticeships inside of the company, to bringing in PhD candidates to work in the company, to, as Owen mentioned, the partnership with Dragons RFC to get into the primary schools. We're reaching literally hundreds and hundreds of kids ages 9 to 11 because we want to start the idea of STEM early, you know, to create the next generation.
Owen, do you want to make a comment on that as well?
In terms of capacity, there are hundreds of graduates coming through the system at Swansea and Cardiff and other universities, but not enough of those are going to supply the industry, the semiconductor industry we're talking about currently. So we need to train more, and we need to target those graduates, push them towards the industry. And we can do that. We've got the facilities, the training facilities to do that, but that costs money. Okay, it costs money to train those students to that level.
Okay, thanks. Got time for one or two more questions? Anyone from the audience? Yeah, on the back there.
Sorry, you put your hand down.
Yeah, thank you. In terms of the industrial landscape of South Wales compound semiconductor, do you think that there's room for other applications outside of power electronics in terms of commercially? I'm thinking like 3.5 microelectronics or micro LEDs or broadband telecommunications in terms of the scale up, I guess, of those material systems.
Rodney? I think the question was, we've talked a lot about power electronics. Is there space for
in
other
terms
technology?
of the industrial landscape, so in terms of the production, obviously you talk a lot about power electronics, silicon carbide, obviously compound semiconductors, there's also 3.5s in optoelectronics and other applications. Is there room for that inside the South Wales cluster?
Yeah. The question is there room for scaling up manufacture of other products as well as power electronics, like micro LEDs, for instance, or is that the question? Yeah.
So the answer is yes, and that's actually what IQE has been doing. So our gallium nitride is actually to the new side of what we do, and so photonics is actually what we've already scaled here. Gallium nitride will be next. The key thing to actually recognize is that it's not about any specific material system within compound semiconductors. It's about the entire class of materials and what they're able to do. And so in that sense, we are a bit agnostic in terms of which of those materials would win. It's much more about what those materials enable. And photonics is certainly there, and power electronics. So compound semiconductors are faster, emit and detect light, much more efficient. And those are the three characteristics that the world needs in just about every technology that's coming out.
Okay, Caroline, do you want to make a comment on that since you're from the LED world?
Yeah, so yeah, I'd echo Rodney's point there about photonics. You know, there's definitely opportunity to manufacture photonics in South Wales. It's not all there yet, but you've got the EPI, obviously potentially at IQE, ICS can do processing. That's the Institute of Compound Semiconductors in Cardiff University. And basically, we can design packaging in the catapult as well. So you have the sort of semblance of a supply chain there. There are companies across the UK that can do, you know, packaging production as well. So I think the answer is for most of these technologies, and also with RF as well, we do a lot of work on RF, or growing amount of work on RF in the catapult as well. So there is a lot of opportunity for RF supply chains around the UK as well, particularly for defence applications. So it's quite, you know, it's often said that we can't do end-to-end in the UK, but actually I think that's changing, and I don't think we're very far away from being able to do it.
Okay, thanks a lot. So I'm afraid we've come to the end of our time slot. So I'd like to thank all of the panelists for their great contributions, and I'd like you all to put your hands together.
Wes, I might ask you to join me once again in thanking our gold partner, Vishay, and our panelists, and our chair, Dr. Drew Nelson. Thank you very much to all of you. Now, thank you to you for an incredible first day at Wales Tech Week 2025. Thank you to our partners, to our exhibitors, and to all our speakers for making it possible. Now, the main schedule is over for the day, but the central bar in the main hall just over there will be open until 7 p.m. this evening for you to continue your networking and your mingling. So do enjoy your evening. We hope to see you again tomorrow. Hwyl fawr i chi, goodbye, and thank you once again for a great first day.